So good evening, everyone. We'll start over again and welcome to the May meeting of the Ozaki Radio Club. I'm Pat, W9JI, President. Let's switch over to our Zoom meeting and let's welcome Carl, K9LA, who's going to talk to us tonight. And Carl's not at the...
There we go.
Great. Okay, thank you, Carl, for joining us tonight. And Carl's the ARRL Central Division Director, in addition to being an author and an RF engineer. And he's going to talk to us tonight about the latest updates on Cycle 25 and propagation. So whenever you are ready, Carl.
Well, hello to the Ozaki Club there. There we go. So I'm Carl, K9LA in Fort Wayne, Indiana. We're pretty far west, but we're still in the Eastern time zone. So at least we won't be changing clocks anymore. That's great. I kind of like that. So what I'm going to talk about a couple, well, actually 4 topics. Cycle 25, some space weather. What is space weather? Well, it's weather that's not terrestrial weather, okay? Hey, how's that for a good definition? Talk about some simple antennas because Cycle 25 is ramping up and the higher bands are kind of good right now, but they're gonna get even better. They're gonna give us some great daily worldwide propagation. So on 15, 12, and 10 meters, maybe even 6 meters, we'll see. And then I'm going to talk about field day propagation very briefly because field day is creeping up on us. And Gary, W9XT, talked about field day last night. So I thought that would be good to do. Now, here's a little bit about K9LA. Got my novice in 61. And just like Gary, I majored in W9YB and minored in EE at Purdue University. I was an RF design engineer. I mostly did solid state RF power amplifiers for commercial and military. I was with Motorola and also Magnavox, which changed names a couple times, finally ended up as Raytheon. Retired in 2013. I enjoy propagation, DXing, contesting antennas, and vintage equipment. And as Pat mentioned, I'm currently the director of the ARRL division. Took over from Kermit when he, I guess you'd say, resigned in July 2021 to spend more time with family issues. You got to remember, he was the central division director and working full-time at Fermilab. So that was pretty good. My wife is Vicky, AE9YL. And I hope to see many of you at the HRO Superfest. That's also the Central Division Convention this year in Milwaukee. And also I'll be at Oshkosh for the EAA Air Venture. Really looking forward to that too. See here, there we go. So here's what we're going to talk about. Those four major topics. Talk about some historical data. It's always good to look at what the other 24 cycles did. Quick look at predictions. Then we'll take a look at the latest data. Just remember, predictions are great, but data trumps all those predictions. And I'll talk about why. Space weather, what I think are the important parameters and what we desire. And also, how can we determine what real-time propagation is doing on the bands? Some simple antennas for the higher HF bands. That's kind of for some of the newcomers. And if you've been licensed in the past 5 years, you kind of wonder what's so great about 15, 12, and 10 meters. Most of the time we heard noise on those bands. But things are going to start picking up. They are showing signs of life. and it's going to get better. And then I'll talk about field day propagation on HF and 6 meters. So let's get going. Cycle 25, it's finally came. There's Jeeves there, looking at the sun and wondering when it's going to get going. And just like the sun in that picture, cycle 25 is starting to pick up too. And it's picking up fairly good too, but we'll take a look at that. So here's a historical look at all the previous 24 solar cycles. That Excel plot shows the maximum smooth sunspot number of each of the 24 cycles. Way on the left is cycle 1. It started in 1755. You've probably heard of the Maunder minimum. That was 1645 to 1715. That was a period of very few sunspots. The sun kind of quieted down quite a bit. We do have sunspot data prior to 1755, but 1755 was deemed when the records were good enough to start history. You can see cycle 1 hit a maximum smooth sunspot number of 150 way back in probably about 1760. Now, what's very obvious from that plot is we've gone through 3 periods of big cycles. You can see cycles 1 through 4 were quite big. Cycles 8 through 11 were kind of big. And then 17 through 23 were kind of big. And of course, in that period, that's when cycle 19 happened. It was the largest in recorded history. Who knows, maybe there were bigger ones prior to us having good data. Now, what's also obvious is we've gone through 2 periods of small solar cycles. Cycles 5, 6, and 7 were quite small. Cycles 12, 13, 14, 15, 16 were small. Not as small as 5, 6, and 7, but still not as good as those 3 periods of large solar cycles. Now, where's cycle 24? Well, it's the one all the way on the right. It's pretty low. In fact, it's the lowest in our lifetimes. It's the 4th lowest in recorded history. Cycle 5, cycle 6, and cycle 14 are smaller. Were smaller than 24. Now, just make a quick comment that during our lifetimes, which kind of has been for us old guys, maybe cycles 19 onward, we were in a great period of big solar cycles. That meant the higher bands were really good. Now, what cycle 24 appears to have done is put us in a 3rd period of small solar cycles. And that's the big question. Will cycle 25 get us out of this 3rd period? Or will it keep us in this 3rd period of small cycles? So next, let's take a look at predictions for cycle 25. Okay, I'm aware of 56 predictions for cycle 25. Why are there so many? Well, that's because we don't fully understand the sunspot generation process. We know it has to do with how plasma flows inside the sun and how the magnetic fields inside the sun move around. But we just don't have the nitty-gritty details yet. So what that does is causes many people to make predictions via several different methods. Now, what you can see, though, is there is a consensus, at least for cycle 25. Now, it doesn't mean it's correct, but most of the solar scientists believe that we're going to have a below average cycle. In fact, 50 of those 56 predictions, that's 89%, are for a below average cycle. You can see the bucket in which an average cycle falls. That's what cycle 23 was an average cycle. And it falls in that 175 to 199 smooth sunspot number bucket. Now, there are also 3 predictions for an average cycle. That's the 3 there under the red annotation average cycle. And there are 3 for a larger than average cycle, but we got to watch it. The original Dr. Scott McIntosh and colleagues prediction was in that 100 or in that 225 to 250 bucket. So that would have been a really big cycle. And it might have rivaled cycle 19. But in August 2021, the McIntosh prediction was revised down to the average bucket. So, and why did that happen? Because a certain event that they expected to happen earlier didn't happen. And that resulted in them having to revise their prediction downward. Again, all I can say is all these predictions are great, but the real data is what tells us what's going on. And it would be nice if all those solar scientists were wrong, but I'll let you know in 2024 or 2025 what happened. Wow. Oh, wrong way. How about that? Okay, so how is cycle 25 doing? Let's see what the actual data says. Now, there are 4 curves on that plot. They all start when the smooth sunspot number numerically minimized. For cycle 25, that was December 2019. And that's what that red thick line is. That's the progress of cycle 25. Now, we have 23 months of smooth sunspot number data. So we're probably close to halfway to the peak. And all we can do is just wait and see what happens. Now, the green plot is what cycle 24 did. Remember, that was the smallest in our lifetimes. The orange plot is of an average solar cycle, like cycle 23. And that blue curve is what cycle 21 did, a moderately big solar cycle. Cycle 21 peaked in 1979, and boy, 10 meters and 6 meters was really good. It'd be nice to have another one of those nowadays, because a heck of a lot more people are on 6 meters than back in 1979. And cycle 22 was also a good one too, and peaked in about 1989. So, what conclusion can we make about cycle 25 so far? Well, unfortunately, so far, and let me stress, so far, we appear to be tracking the smaller cycle 24. Okay. Now, if you've been active on the bands recently, specifically 15, 12, and 10, you know that we've been having some good propagation on those bands, even sideband and CW propagation. Last night, JT1CO was on 15 CW about 9 o'clock with a good S7 signal here into my QTH. So there are openings, but cycle 25 isn't high enough yet to give us daily worldwide openings on 15, 12, and 10. We'll get there, but we're going to have to wait a little bit. Now, also note where each solar cycle started in terms of its smooth sunspot number. You can see that cycle 25, the red, started at pretty close to 0. And also cycle 24 started way down there too. Notice that as the smooth sunspot number, the minimum smooth sunspot number goes up, it gives us a bigger cycle. So I took a look at all 24 cycles and looked at where the cycle started in terms of the smooth sunspot number, and then how big the next cycle was. And there's some correlation, but it's not really good enough to claim anything yet. So the only thing we can do is wait maybe 6 to 12 more months and get another 6 to 12 more months of data on cycle 25, and that hopefully will tell us what cycle 25 is going to do. all I can say is while we're waiting, sit in the chair, keep your butt in the chair and make some contact. Now, since we still don't have daily worldwide openings on 15, 12, and 10 meters, mostly we're seeing a lot of north-south propagation. Keep an eye on the daily sunspot number and the daily 10.7 centimeter solar flux. This is a website, solen.info/solar. It's a 1-year view of the daily 10.7 centimeter solar flux in black, the daily sunspot number in red, from May 31st, 2021 to May 9th, 2022. Now, off to the left of the chart, you see there wasn't much spikiness in the data, in the sunspot number and the solar flux. That's because we were coming out of solar minimum. Now, you can see what's happening as cycle 25 is rising. We're getting more and more spikes, and that's just going to happen as we move up as cycle 25 ascends. Now, I also highlighted a specific date in green. That was CQ Worldwide DX phone contest in 2021. You can see the sunspot number spiked up. The solar flux spiked up on that weekend, and we had great results on 15, 12, and 10 meters. So keep an eye on that. If those spikes happen to fall on a contest weekend, that's probably going to help very, very well. See what happens. WPXCW is coming up pretty soon. We'll see what happens as that data is updated. Oh yeah, okay, that's our cat. Yeah, he's making noise. Let's see what else. So let's talk about space weather real quick. There's a lot of data out there. There's a K index, SN, A, X-ray flux, SFI, B sub Z, and all that stuff. So what does all that mean and which ones are important? Well, this is going to be kind of brief. Really talking about space weather and propagation could be a whole nother presentation. So what I like to look at is the data that N0NBH puts together. And this one came from QRZ.com. His banner in a different format, it may not be square, it may be rectangular, whatever, shows up on a lot of other websites. But here's the one I pulled from QRZ.com. And what I've highlighted in gold boxes are the parameters that I think are kind of important to look at. And they'll give you a general idea of what's going on. Okay, SFI, that's the 10.7 centimeters solar flux index for the day. You can see, let's see, I took this today at 1649, so that'd be about 11:50 your time this morning. Solar flux today is 116, okay. SN is the sunspot number. It's 62. It's kind of gone down a bit in the past week or so. Now there's, ow, dang it. The cat has got me. Oh, well, geez. There's also at the bottom, there's a MUF US Boulder. And what that is the maximum usable frequency over the Boulder ionosonde at the time on the given day. Now, Gary talked about MUF's maximum usable frequencies last night, but what Boulder is, that's a great location for a path from the Midwest to California, because it's about halfway in between. And the path from the Midwest to California is around 3,000 kilometers. And that's what that MUF is derived from. So it's 18.3 megahertz for a 3,000 kilometer path centered over Boulder. So that'll tell us that like this morning at about noon your time, probably 17 meters was open to California. Now that's also a good indication of what the MUF could be in the continental United States at a little bit higher latitudes, it's going to be a little bit lower. At lower latitudes, the MUF is going to be a little bit higher, but it gives you just a kind of a general idea what's going on. Now, so what do we want the solar flux and the sunspot number to be? For daily worldwide propagation on 15 meters, the solar flux index has to be not greater than 90 for a long time period. Not just a day or two, or not just a spikiness for a week. It really has to allow the ionosphere to build up as we ascend cycle 25. That also correlates to a sunspot number greater than 35 for a long period of time. And we're kind of getting there. That's for 15 meters. Of course, 10 meters, we need more flux and more sunspots. Let me mention that the true ionizing radiation of the F2 region is extreme ultraviolet radiation. So sunspots and solar flux are just proxies for the true ionizing radiation. Now, what about the K index? Well, when I downloaded that banner, K was 2, not bad. K index is the 3-hour indication of how the Earth's magnetic field is doing if it's disturbed. K is a logarithmic scale. It goes from 0 to 9. 0 is very quiet, 9 is very disturbed. So K equal 2 indicates that things were generally pretty quiet. The B sub Z, well, that's the Z component of the interplanetary magnetic field, or the Z component of the sun's magnetic field. Now, the Z component is perpendicular to the ecliptic. What's the ecliptic? That's the plane in which the Earth goes around the sun. So think about that. If something is perpendicular to the ecliptic, it kind of says it's north-south, just like the Earth's magnetic field. So that's going to tell us how well the interplanetary magnetic field, the solar wind, is coupling into the Earth's magnetic field, which could screw everything up. We'd like BZ to be positive. Slightly negative is okay. When it gets largely negative, that means it has turned south, and that couples very well into the Earth's magnetic field. That'll screw up the F2 region. SW is solar wind. On average, it's about 400 kilometers per second. When there's a big CME headed right towards us, or a coronal hole, it could get up to 2,000 kilometers per second. Now, one thing I should mention is solar flux and sunspot number are, and the MUF US boulder are kind of correlated. So when the solar flux index is high, the sunspot number's generally going to be high, and the MUF US boulder is going to be high. Likewise, for the K index, the BZ index, and the SW index, they're very correlated. When the K index is low, the BZ index will be positive or just slightly negative, and the solar wind speed won't be too high. When the K index is 6, 7, 8, 9, that means BZ is going to be very highly negative, minus 50, minus 100, something like that. And the solar wind speed is going to be much, much greater than 400 kilometers per second. So there's some general guidelines for what the bands are doing. But really, it doesn't tell us exactly what the bands are doing right now, or what the ionosphere is doing. So how can we tell what's really going on right now? Well, one thing to do is go to dxmaps.com. You can see I've selected a world view, and I've selected 15 meters. And I pulled this this morning about noon your time. And what you can see is the east coast of North America was working into Europe, working into South America, and it looks like into the Pacific. Now, waiting a little bit, a couple hours later, it probably would have gotten better as the F2 region was building up. But that'll tell you who's working who. It comes from spots, and all you do is plot the one end of the spot and the other end of the spot. It tells you what's going on. I also looked at 6 meters this morning at the same time, and there was some decent sporadic E over in Europe, and there was a little bit of sporadic E over here in the east coast of the United States. There's some other methods to tell what the bands are doing right now. One is Kilo Charlie 2 Golf has a MUF map. He downloads ionoson data, then adds contour lines. It's a worldwide view. He updates it every 15 minutes. So that can give you an idea what the worldwide maximum usable frequency is. Of course, PSK Reporter can show what's going on. WhisperNet can too. The good old reverse beacon network, transmit in a certain format, and you go listen to SDRs around the world and see where you were received. It's a great way to check two antennas, see how antenna A is doing versus antenna B, as long as there's no interaction between the two antennas. And of course, there's the IARUNC Northern Cal DX Foundation beacons. There's 18 of them worldwide. There's some more coming online. Each of the 18 beacons transmits for 10 seconds on a given band. So in a 180-second period, 3 minutes, you can tell what worldwide propagation is doing on either 20, 17, 15, 12, or 10 meters. There's some software called Pharos, F-A-R-O-S, that was developed by VE3NEA. And you can tie your PC to your radio so that you know exactly which station is transmitting in the 10-second interval. You can even collect data on signal strength. And you can look at some pretty interesting propagation results from that. So there's lots of ways to find out what's going on right now. So as we ascend cycle 25, we got to start talking about disturbances. We've had a number of big solar flares so far, and unfortunately, it's probably going to get worse. That's because as cycle 25 ascends, the coronal mass ejections and big solar flares are going to start occurring more and more, and they're most prevalent around solar max. Unfortunately, we have to take the bad, CMEs and big solar flares, with the good, which is great propagation on the higher bands, because more sunspots means more extreme ultraviolet, means a stronger F2 region. Like I said, CMEs are most prevalent around solar max. They cause geomagnetic storms. In other words, the K index is going to be elevated and the F2 region will likely be disturbed. In other words, the MUF will be lowered. Big solar flares are most prevalent around solar max. There's two effects from big solar flares. Big solar flare is, like an M, a 789, and an X class flare. If the flare emits relativistic protons, in other words, very highly energetic and also very fast, they can funnel into the polar cap, and they can cause increased D region absorption in the polar path, in the polar cap, which means that's going to affect over the pole paths. And you guys have a little bit more problem with that than over here in Fort Wayne, but if you're working into India, we both have the problem. Big solar flares can also emit X-ray radiation, and that causes radio blackouts on the daylight side of the Earth. Now, coronal holes, they're most prevalent during the decline of a solar cycle. And in fact, they can be worse than CMEs. They go on for quite a while and can be come around on the next solar rotation even. How about 12 meters? Well, things are getting smaller as we go up in frequency. An inverted V, each side's only on 9¼ feet or so. A dipole made with aluminum tubing. The easiest way to feed it is to split the tubing in the middle, put like a fiberglass insert inside the two pieces of aluminum tubing, and then just go through a balun and hook your coax to the each side of the dipole. 2-element Yagi's even smaller than 15. And we're getting into the area where maybe even a 3-element Yagi with more gain and better front to back might fit inside on your lot. And again, we're not talking, you don't have to put it up, 60, 70 feet. If you get it up 20 feet or something like that, 30 feet, you'll do real good. How about 10 meters? Well, a dipole, aluminum dipole is only 16½ feet tip to tip. And it's going to give great results, 15 to 20 feet. If you watch Gary's presentation, he showed you how the major lobe changed versus height, and of course it's electrical height is what's the issue. And if it's 20 feet on 15 meters, 20 feet on 10 meters is even electrically higher. And that means the low will be lower. So, 20 feet, it's pretty good, should be pretty good. Multi-element Yagis are quite reasonable. I have a 4-element Cushcraft 10-meter Yagi. There's its azimuth pattern. We're looking down on the antenna. Nice forward lobe and not much radiation off the back and the sides. It's on a 16-foot boom, and elements are about 17 feet tip to tip, so it's not really big. It's not like a 20-meter Yagi, which will be twice as big. And I've used it to work many stations with my little homebrew QRP 10-meter double sideband transceiver during the big solar cycle 22. And I'm looking forward to doing that again when cycle 25 gets good enough. The 1-watt PEP is it's kind of low, but I worked into South America and stateside, so hopefully cycle 25 will do good, and I'll have the 4-element 10-meter Yagi to play with. Okay, how about some field day propagation? I'll just remind you, I've mentioned Gary's presentation last night, and he talked about antennas. And he talked about what he does to maximize QSOs on field day on 40 meters. Might want to take a look at that with field day coming up. It was recorded and it is available at that URL. All you have to do is go to the Madison DX Club website and look at programs. There's I think it's way on the left there, a link, and you can look at all the previous programs that were presented. Very good. So what about HF? Well, just some very general comments. 80 and 160 should be good at night, unless there are thunderstorms, which, we're in late June, so that's a possibility. Might help to have a receive antenna to minimize noise. A little small loop might help out quite a bit. 40 meters should be good during the day for shorter distance QSOs and should be good at night for longer distance QSOs. 40 is one of the bread and butter bands in field day. The other one is 20 meters. Should be good during the day. Are there enough sunspots to keep it going nighttime? Well, we'll have to wait and see. 15 and 10. It's iffy. If sporadic E doesn't occur, look for mostly north-south paths in the daytime. If sporadic E does occur, well, you may have to look everywhere. because there may be multiple sporadic E openings. And when does sporadic E happen? Well, that's what the next slide looks at. There's a plot of its probability versus month and local time. The horizontal axis is month for 2 years. The vertical axis is local time, with 0 being midnight and 12 being noon. Now, you can see that there are contour lines. That's the probability. And you can see in the summer months, the best probability, the highest probabilities are in the late morning and early evening. But don't forget about in between. You can see the probability doesn't go to 0. It's a lower probability. So always, have a station there on, if you got a 6-meter station, just keep an eye on 6 meters. We've already had some sporadic E openings, and hopefully things will be good for late June. So this is a picture of short-term sporadic E openings, late morning, early evening in the summer months. What about longer term? Well, VE3EN took some data from 2004 through 2014, 11 years of data. And he looked at QSOs between Eastern and Western Europe to the eastern half of North America. Now you can see what call areas he considered the eastern half of North America. It includes the 9th call area and a lot of Canadian also. And he only took data when there were 5 or more contacts between multiple stations. So it wasn't just, one guy made a QSO and that was it. There were multiple QSOs. And the y-axis is the percent of the 11 years that QSOs were made. Now, if you can see on that chart, like for example, late June, you can see that the probability from the vertical scale is up around 70 to 80%. So 8 of those 11 years had sporadic E openings in late June. Now, remember, that's from eastern half of North America to Eastern and Western Europe. But it's still gives us a general idea that what sporadic E could do even for the continental US. You can see that it looks like sporadic E starts in mid-May and goes through mid-August. So VE3EN, he's the guy that has put together the solarham.net website. Lots of data. So here's a summary. Cycle 25 is in its ascent. Solar maximum, probably around 2025, kind of depends. If its rate of ascent increases, it will maximize earlier. Is it going to have 2 peaks like the previous several cycles? We can't even predict the maximum of a cycle very accurately yet. So I'm not sure any prediction of how many peaks there are going to be would be worthwhile. So far, it kind of looks like another small cycle. And of course, probably in 6 to 12 months, we'll have more data, and we may be able to, we may have a better idea where it's going. Now, even if it is a small cycle, solar maximum is still going to offer worldwide propagation on a daily basis with modest power and modest antennas on those higher HF bands, and even on 6 meters. And all that'll happen in the fall and winter months around solar maximum. Cycle 24, smallest in our lifetimes, but it had great propagation on 15, 12, and 10 around its maximum, especially the second peak. Of course, the digital modes offer an advantage over CW and sideband. It's because they can decode a signal farther down into the noise. And that is a significant advantage on 10 and 6, especially now when cycle 25 isn't as strong as it's going to be. Of course, take advantage of the summer ES season on 10 meters and 6 meters. FT8 is going to really shine, I believe. I've also already seen FT8 spots on the 6 meter sporadic E. And we have tools on the internet to determine what the bands are doing right now. So that's a good way to kind of bypass all that space weather and just go see what's going on in the bands, because what you see on the bands happening takes into account all the space weather. And so it's a great way to see what's going on right now. And here's some references if you want to go take a look. Like I mentioned, the N0 NBH banners at QRZ.com and a whole bunch of others. Dr. Tony Phillips writes to spaceweather.com. Not only does he have space weather parameters, he has lots of good text on various phenomena. NOAA, the SWPC, the Space Weather Prediction Center, they get a little bit more detailed into more technical type data. Lots of good pictures of what's going on. I mentioned VE3EN at solarham.net. It's got all the space weather parameters. And of course, Dr. Tamitha, Whiskey X-Ray 6 Space Weather Woman. She has her regular videos telling us what the sun's doing and how it's going to affect us. Now, there are a lot of other websites out there, and if I missed your favorite one, it wasn't on purpose. It's just I can't list them all. Now, if you're interested in just learning about the sun, that website is the Marshall Space Flight Center, MSSFC, and it's a great tutorial on the sun. You know, how big it is, how hot, how long does it take the sun to rotate, and all that stuff. Really good. And of course, if you're looking for propagation and antenna references, there's the ARRL handbook and the ARRL antenna book. The CQ Shortwave Propagation Handbook, 4th edition, was revised in late 2021. Well, mid 2021, I guess. And Bob Brown, NM7M, who's a silent key, wrote a great little book, The Little Pistol's Guide to HF Propagation. It was in 1996. It's a very easy read. It's not a technical book. And it's very easy to read and understand a lot. The book is out of print, but it's on my website. It's 15 meg, which nowadays shouldn't be too much of a problem unless you're way out in the boonies somewhere. Of course, there are many other references out there too. And again, I apologize if I missed your favorite one. I just can't list everything. Lots of good information out there. So that's all I had. If there are any questions, I can entertain them and hopefully advertise them or answer them.
Okay, thank you, Carl.
Yeah.
And Carl, I have a question for you. This is Pat W9JI.
Sure.
You mentioned with your vertical antenna that you used a couple of elevated radials. Do you have
Yes.
elevated radials for each of the bands that you operate on, or do you have those in addition to like a large number of on the ground radials?
No, I just had, in fact, I had them on the ground and just 2 radials for each band. I also had it on the roof of the garage, which is 1 story, so it's not that high. And again, I just put up 2 radials for 10, 2 for 15, 2 for 20. And pretty simple installation. And I remember I used it at 100 watts in ARRL DXCW during the last peak of the solar cycle. I worked about 90 countries on CW. So a vertical can do good. We live in a rural area north of Fort Wayne on a couple acres, so we can do anything with towers and antennas. And our noise is quite low, so that certainly helps.
Okay, that's of interest to me right now because I actually have a vertical antenna that I'm going to be putting up this summer. And I have a pole that I can put it on that'll get it up about maybe 6-8 feet in the air. And I was thinking some elevated radials high enough up in the air to walk under might be, be convenient. So
yeah, we got deer here too. So elevator radials are probably about 7 or 8 feet for me on my 160 meter inverted L.
Okay, very good. Thank you. Questions?
Did we record the whole thing?
I think we've recorded probably 90%.
Just missed a little part of it. Okay.
Yeah, I will send a PDF of the presentation, so maybe that can fill in what was missed.
Okay.
I have a good story about when I had some 80 meter beverages. They were only 3 feet above the ground. And there was a whole bunch of deer out in the field to the west of us. And they were having a grand time. And when they ran, they ducked under the beverage. You know, they knew it was there and they went under it. And that was pretty interesting. I think they were all does. If it would have been a buck, man, that might have been a problem with his antlers.
Well, I think having them duck under it is better than having them run into it.
Right. Oh, they could easily.
Carl, you must have smarter deer than we have in Wisconsin. I had some temporary antennas out and I left the coax laying, well, it was kind of half laying on the ground and half sort of strung up toward the house. And it didn't take the deer more than 24 hours to run into it and pull everything down. So, and it's happened twice to me now.
You probably didn't hang any signs that said, beware the wire, right? Yeah.
I'll do that next time.
Okay, good.
Yeah. And just a comment, I guess, while I'm here, you started talking pretty much at 15 meters and up. But I found I've been working a fair amount of digital and 17 meters lately. In the last month or two has been phenomenal. So at least for me, I'm pretty new at it. So 17's already taking off.
Oh yeah, lots of good. See lots of good spots for the VU4W and 9N7. I think CI, and there's another one. I don't know what. 9N7NE maybe, I don't know, whatever his call is. But yeah, 17's doing really good too.
Okay, any more questions?
Kyle raised his hand.
Oh, go ahead, Kyle.
Hey, those elevated radials, you might want to put telltales on it so that the animals would see them better. You tie a little ribbons every once in a while.
Yep, good idea.
There you go. Thank you.
Okay, thanks. All right, thank you very much, Carl.
You're welcome.